Hello and welcome back. Now I'll be going over using player success to predict team success. I used a few methods during this section. First, I used the response variables from the players, Corsi for versus quality of competition, and from the goalies, goals carried above average, to try and predict a team's success, points. I also then tried to use the predictive variables from the players, so every single one of the predictive variables that described, for instance, a forward's Corsi for versus quality of competition. Finally, I used a mixture of forward and goalie response variables as well as defensive predictors. Data was weighted against a player's time on ice to most accurately reflect a player's contribution. So, a player with 10 minutes of ice time would be weighted differently than a player who played 28 minutes of ice time. This was done to ensure that players were properly reflecting their contribution. All of the methods were used to try and predict a team's regular season points based on their players' contributions. Using the response variables such as Corsi for versus quality of competition and goals saved above average, the regression output after doing various regression diagnostics yielded a model that contained no defensive stats as predicted variables. This seemed inaccurate as all of forwards, defensemen, and goalies are important to a team, yet defense was not included in this predictive model. Notice that offensive Corsi for and goals saved above average are the only stats in this predictive model. Using the predictive variables for each of the response variables was then used to create a regression model for predicting a team's points. After regression diagnostics, the model yielded only defensive predictors. This, again, seemed inaccurate. A team is made up of much more than defensemen. At this point, we had one model with no defensive stats and one model with only defensive stats. The third model used a combination of forward and goalie response variables and the defensive predictive variables. Perhaps it was a certain combination of defensive predictors that was more accurate in predicting the team's success than the response variable. However, after building the model, the forward and goalie response variables were again excluded from the final output. So we can conclude that the model for using team stats to predict the success of a team is better than the regression model we tried to use building weighted stats, using the response variables for the player success, as well as the predictive variables for the player success. What this means is there are likely other stats that predict a successful player that also better explain a team's success. Another possibility is that defensemen are way more valuable than you might think, or not valuable at all, which means this conclusion is relatively useless. We should also keep in mind that all of these stats are 5-on-5 stats. Special team stats such as power play, which is when you have 5 players on the ice and the other team has 4, and shorthanded stats, which are when you have 4 players and the other team has 5, likely play a big role in a team's success. Finally, do better players predict a team's success? We need to do further analysis. Our model lacks special team stats, and the player and team models are very accurate at predicting success as we have defined it. However, those measures of success don't necessarily define a team's regular season success. Another thing to keep in mind is that these are only statistics. External factors like coaching style or how well you get along with your teammates aren't considered in the models. This concludes our project. Thank you all for watching.